Hello, nice to greet you. My name is Jorge Palafox and this is my project. Sustainable consolidants based on chitosan and calcium hydroxide nanoparticles from waste. First, in context, Mexico has in the top 10 countries heritage sites listed of UNESCO, and my state, Guanajuato, has more than 6,000 sites cited of INA. One example is the Monumento a la Paz, made of bronze and marble. The marble is a calcareous material. Maintenance for monument is expensive, and for this reason we propose synthesize one from waste like egg and shrimp shell. Both waste are a high volume production in Mexico. From eggshell we can obtain calcium oxide and then calcium hydroxide nanoparticles. This is very common calcareous consolidant stone. Shrimp shell is composed of chitin, and from it we can obtain chitosan for compatible calcareous stones. For each one, we made two syntheses. Chitosan was extracted from shrimp shell by thermoalkalinic method, described at the following image, and nanoparticles from eggshells by calcination method, described at right. Both components was solubilized or suspended in isopropanol respectively and compared by magnetic strict indifference radio. Finally, we apply consolidant solution on marble specimen by brush. The chitosan synthesis was made of lab scale reported and scale-up proposal made by your group. The shrimp shell was recollect from restaurants in three presentations: cooked, pre-cooked, and raw. First, we analyze the product by infrared in ATR technique. With the results, we take two representative peaks for desacetylation degree. This is a characteristic very important due to that it has a relationship between viscosity, molecular weight, and application properties. We compare spectrum and results with merged chitosans. As you can see, for desacetylation degree results are higher than 85% and higher for Merck chitosan. For the three presentations, there is a no difference between desacetylation degree from the like scale and scale-up batches. For evaluate consolidants that we synthesize on marble specimens, this was characterized before and after by hardness leaf instrument and colorimeter by SA8 lab. For each one, the results, as you can see, we evaluate the application before and after the treatments. As you can see, nanoparticles improve hardness leaf in comparison with we only use chitosans. Then we evaluate the colorimetric and visual evaluations. For this one, and as you can see, the chitosans formed a field on surface specimens. This behavior disappears when we increment the nanoparticle radio. All specimens there is not visual change and aesthetic aspiration after the treatment. To corroborate these conclusions, we evaluate total change color by CA lab method. The result shows that all of the treatments doesn't have total perceptible colors. All values are less than 5, the limit reported. In conclusion, it's possible to obtain calcium hydroxide nanoparticles and chitosan from agroindustrial waste. The proposed scale of synthesis chitosan by our group provides chitosans with similar desacetylation degree compared with lab scale. Adding nanoparticles to chitosan improves average surface hardness on marble specimen without aesthetic alterations. The best consolidation solution was chitosan and nanoparticles was on the 0.4 radio. We want to express or acknowledge to CONACYT for support the project, to the University of Guanajuato for following people of these institutions, and here is my reference. If you want to explore with more details each one, you can scan the QR code. Thank you for your time.